So the project itself is Warwick Human-Powered Submarine. The aim of the game is to build a one-man, fully flooded, human-powered submarine. So you've got a pilot in it who lies prone, they pedal, and that powers the submarine along a race course. At the end of this year, it's going to be racing a 100-metre sprint in the US. It's a legacy project, so this team has only been working on it since about October this year.
So I'm working on the steering with Joel. We would message each other and say what ideas we have, and then like one day in the week we meet up and start designing it in CAD or something like that.
Yeah, it might be sort of quite an informal discussion, so
yeah.
I'll just go over part of the design with Lewis. And another day, because I'm part of the finance team, Ash and I will work on the finance. So we'll have these sort of sub meetings as well as the big group meetings we have every week, where we'll bring everything together, try and demonstrate what we've been looking at, what we've been researching, and see how it integrates.
My technical role is working on the powertrain. We want to put an electrical steering system in there with an integrated mechanical backup. Of course, a huge issue there is waterproofing, and it's all very well saying, oh yeah, my watch is waterproof or whatever. Yeah, it's fine if you drop it in the bath, but that doesn't necessarily mean it's going to be waterproof at 6 metres where the pressure's gone up by half a bar.
The idea that's being thrown around the most is let's just coat it in plastic.
We want to implement a direct drive. This will include a right angle gearbox, so it looks a bit like that, T-junction. And normally you have one input going to two outputs. What we want to use it for is the other way around, because the person's pedaling, so you have two inputs, one from each pedal, and then one output directly to the propellers. Unfortunately, most right angle gearboxes are not designed to withstand that. So while they'd be perfectly happy to take the torque we need in one direction, they are not so happy to take the torque in the opposite direction.
I'm doing the Arduino and the steering and the control, because I don't want to do a new design. I'm basing my design off last year's design. The guy that designed it has now left, so I have to use his circuit diagrams and code to make my version of the steering, which is quite hard because you can't really ask anyone about the code because he's gone now.
I'm looking into materials that we're using to actuate the steering. So I've been using a lot of finite element analysis just to optimize it, but also to look for the correct material to use. We'd love to do more stuff with 3D printing, because that's an area that we've had a lot of success with in the past, and it's really versatile.
Primarily, of course, there is the submarine pit in the IMC workshop. Also the engineering build space across in the School of Engineering, so if we need to 3D print anything that's relatively small, if we need to go and ask some technicians their opinions on something. There's also a lot of academics who are really heavily invested in this project. What next year we think are going to work on is actually the hull itself, which is currently very circular in cross-section. What we think they want to do is reduce it from this kind of shape to a very much more upright oval kind of shape, which will reduce the volume considerably, and of course less volume means there's less water in your submarine, means the pilot's doing less work, and can therefore go faster for the same amount of effort. Obviously, aim of the game is to make the submarine better, to move faster, to make it to the other end of that racetrack.